Video we're going to talk about U substitution with definite integrals, right? So let's look at the first example. We have this integral here. The first thing I'm going to do is rewrite this integral. So I'm going to say this might as well be the integral from 2 to 5 of, you know, 1 over 2 times 2x minus 1 to the 1/2 power. So this is 1/2 to the 1/2 power dx. I just like my stuff like that. I'm going to rewrite this again, and I'm doing this in steps from 2 to 5. Notice that this 1/2 is multiplied by this whole thing here. This 1/2 is multiplied by this whole thing here. And I'm sorry, guys, there should not be a 2. There should not be a 2. So that 2 shouldn't be there. I was tripping. Well, the 2 belongs here. So I was tripping. I was like, what? Okay, so I'm going to rewrite this integral of 1 over 2x minus 1 to the 1/2 power. And again, I could rewrite this integral by flipping this 2x minus 1 into the denominator and just attaching a negative to my 1/2 there dx. And this is the same thing as this. So now that we have something in a plausible direction, notice that we can't just use the n x to the n plus 1 rule here. So now we're talking about U substitution. So what will your U be? Well, you only have one option. So in this case, my U is going to equal 2x minus 1. Taking a derivative of this, so du will just be 2 dx. Well, look what happens. I have 1 dx and maybe I should attach a 1 here. I have 1 dx, right? I do not have 2, but that's okay. We could fix that. So dividing by 2 on both sides, I get 1/2 du is equal to dx. And I just factored out my 1/2 here. This is the same thing as du divided by 1/2. I just decided to write it like that. All right. So now that we have a 1/2 du that will substitute for an x. Now here's a trick with definite integrals. We could do this 2 ways. I'm going to show you the way that I prefer, and believe it or not, it is probably the more shorter way and the more simpler way. So this is what I'm going to do. I'm going to make this rationale. Since x is equal to 5 from here, then u has to be equal to 2 times 5 minus 1. And all I did was make this rationale here. If x is equal to 5, I plug 5 in for u, right? And since x is equal to 2, u is equal to 2 times 2 minus 1, right? And this is just 9, this is just 3. And what this allows me to do is set up my integral in a different way. So I could rewrite my integral from 1/2, right? I'm going to factor in my 1/2. This comes from this 1/2 du from 9 to 3, from 3 to 9 of u to the negative 1/2 du. And this is my new integral. Now I could go ahead and use my x to the n plus 1 divided by n plus 1 rule, right? So this is just 1/2 u to the 1/2. And I'm going to divide this by 1/2. But because I do not want to get a complex fraction, I'm just simply going to take the reciprocal of 1/2. I'm going to multiply by 2 instead, right? And this all will be evaluated from 3 to 9, right? Notice that these are being multiplied, so these 2 could cancel here. All right, so now I have something that looks like this. My u now is going to be, well, my integral now will be u, or the square root of u, doesn't matter, u to the 1/2, evaluated from 3 to 9. And now I could just plug in my values, right? So this should now be the square root of 9 minus the square root of 3. Square root of 9 is 3 minus the square root of 3 is just 3, right? And this will be my final answer. Let's do some more practice. How about this? The integral from 1 to 0 of e to the 2x minus 1. Well, again, my u in this case will be 2x minus 1, right? I'm going to set my u as equal to 2x minus 1. And how do I know that? Well, again, a lot of times when you're dealing with exponential functions, your u will most likely be the thing that's up in the exponent, all right? Just keep that in mind. So my u is going to be equal to 2x minus 1. So my du will just be 2 dx. Now, maybe I should have a dx here, right? Now, notice that I do not have 2 dx, but 1 dx, but that's okay. We can fix that, right? So if I divide by 2 on both sides, well, 1/2 du is just equal to dx, right? Now, this is evaluated from 0 to 1. So here's my rationale I'm going to use. Since x is equal to 1, then u has to be equal to 2 times 1 minus 1. Since x is equal to 0, then u has to be 2 times 0 minus 1. And this will give us 2 times 1 is just 2, 2 minus 1 is just 1, 2 times 0 is 1, and that will be negative 1. So these are the new values that we're going to integrate our function from, right? So rewriting my function, right? This will be from 1 to negative 1 to 1, right? Notice we have 1/2 du, so 1/2 du will take care of our dx. And now we just have something like e to the u, right? Because this was your u, we did nothing with e, so e has to be there, and we set this equal to u. So this will be your new function, substituted function that we can now take or integral of, right? So take an integral of this. Well, the antiderivative of e to the u is just e to the u. So this will be 1/2 e to the u evaluated from negative 1 to 1, right? And I'm going to factor out my 1/2 here. So this will be 1/2 e to the 1 minus e to the negative 1, right? And then simply, I could rewrite this as 1/2 times e minus 1 over e, right? And this will be my final answer. No more simplification needed.